In this video, I'm going to walk you through lesson 8 of unit B1. Now, this lesson is actually the end of the second lesson set where we're going to be figuring out ideas about complex ecosystems. After this, we're going to go back to the conservation profiles in lesson set 3 and talk about conservation efforts. So here we've got a few science ideas left to develop in this unit, and it's going to be all about keystone species, biodiversity, and resilience of an ecosystem to disturbances. And so you can see all of what we figured out is right here by the end of the lesson. So let's jump in. We're going to start by breaking up the class into 8 groups. We're going to jigsaw an article or cards, I guess what you call them, and they're going to look at one component of the Serengeti ecosystem. This is the handout. You're going to print out probably only a few copies because let's say you've got 8 groups. You will need 4 copies of the dung beetle card for the 4 people in that group, 4 copies of the gazelle card. And so you just need to do your math. You can reuse them from class to class. Color is best. I do talk in the materials video about maybe just putting that on a digital platform as well if you don't have access to color copies. And so students are going to actually use that handout in a group, and they're going to discuss and answer the questions in this handout. There is an answer key. I'm going to open that up. You can see that students are going to record the answers based on their card. And so if they're researching dung beetles, everything will be talking about that. What components of the system do they interact with? They're going to use the card to help them answer those questions. Okay, then we're going to introduce the SAGE modeler. Now, the SAGE modeler is a computational model, and there's a template that we're going to use. There is teacher reference. These are directions. You're going to need these directions to kind of learn how to use the SAGE modeler. Do this before you do it in front of the class. This day 1 SAGE modeler is done as a group in front of the class. Let me open it up and show what the template looks like. Okay, so here's the template. When you open it up, all of these components that they just researched are already uploaded into this model. And the beginning of the model is also here. So you can use this to kind of introduce the SAGE modeler. So you've got wildebeest here. You've got these interaction arrows between. You can see a negative interaction because the wildebeest eats the grass. That negatively impacts the grass. The grass feeds the wildebeest, so that positively impacts the wildebeest. Now use the directions to help you understand how to click on an arrow to label it or double click it to open this graph. You can see that you adjust these. It increases it by a lot. This helps it become a computational model. And so there's also a way, read the directions that you're going to simulate. And so these bars happen. So when there's a lot of grass, you can see what happens to the wildebeest. When there's no grass, you can see what happens to the wildebeest. Although I think I have to save it before it actually moves. You'll have to play with this, but let me go ahead and get out of my simulate. And if I want to save it, I need to go over here and I need to save, and it saves to your Google Drive. You're going to simply also just move components in. And I just want to show you one trick I figured out. When you use an arrow and you're trying to connect to something, make sure it highlights that wildebeest. See how it glows? That means it's going to connect the arrow. Okay, I'm going to go ahead and undo that and move this back here. That's the basics of using the SAGE modeler, but play with this before you do it in front of the class. So this one is done in front of the class. We discuss the mechanisms. It's a building understandings discussion about what we notice happening. And what we're going to notice is that that wildebeest is connected to a lot of components. And so we developed the idea of keystone species, and that a keystone species, we're going to add this to our personal glossary, is connected to a lot of components in an ecosystem, and it helps make a stable system. That's the big idea from day 1 SAGE modeler. Now, at the end of this day 1, we're also going to add biodiversity to our personal glossaries and officially put it in there. Now, at the end of day 1, you're going to need to save that model that you made for period 1. For period 2, they're going to be different because you're going to make this in front of the class, as they say, add a gazelle, add the dung beetle. They're going to tell you what to do, and you're going to model how to use that computer simulation. And then at the end of the day, you're going to add fire, rain, and disease to each model. And you're going to save a copy, and you got to give a link to that copy to students. Now, if you do not have devices for everybody, you could simply just do day 2 with the whole class like you did day 1. But it is nice for students to have to manipulate the Sage modeler on their own. And so students are going to use a handout. You can see the handout is right here. They're going to make some predictions about what will happen when they adjust the computational model. If the wildebeest have this estimated size, what's going to happen during the disturbance, and then they're going to test these disturbances and talk about what happened. And here are the instructions. You'll want to print this out for students to use the Sage model, modeler, computational model on their own. And really what they're going to figure out, and we're going to discuss this in a consensus discussion. And here are some key questions to help you come to these ideas, is that the Serengeti ecosystem is really resistant to these 3 disturbances because of high biodiversity. So we're really going to develop the idea of resilience, and that it's really important to protect the wildebeest migration because they're creating a very stable ecosystem. If you remove the wildebeest, or we hurt the wildebeest in any way, then the whole system could collapse or become unstable, using that cross-cutting term, stability, change in stability. And so it's really important to protect that wildebeest migration. We're going to then update our progress trackers with all of these science ideas that we kind of figured out. But really what we're going to do is navigate to the last lesson set. We're going to revisit the driving question board to do this. What questions can we answer? What do we still need to figure out? Well, we still don't know how all of these ideas help us make decisions on how to protect lands and water. And so we're going to go back to the conservation profiles in the next lesson set. And also we're going to look at some proposed roads in the Serengeti, and how would we make decisions on which road and which proposal should be the one that is chosen based on all these science ideas that we have figured out. All right, let's talk about materials prep next.